Hey everybody. I don't know why I had a frog in my throat. Okay, so we're going to talk about the normal distribution. The normal distribution is the most common distribution. It is used, um, the normal distribution, it's a model, like it illustrates various things, blood pressure, um, grades, pretty much 75 to 90% of things that occur in the world will occur on this model. I'm dog sitting and is yeah. Okay. We're gonna try and ignore it. All right. A couple of things you need to know. Ruby, stop. A couple of things you need to know about the normal distribution. Let me come right back. All right, guys. I think I calmed the dog down. Um, and so let's talk um, about the normal distribution. So I tried to, in this part, like with this concept, keep most of the stuff typed because I know my handwriting's really messy. Um, and so that's why you're going to see a lot more typed. I'm trying not to just like read it to you. I want to explain it to you. So keep that in mind as we go through this set. All right, so the normal distribution, remember it's that guy. And this is the mean. And this is the mean minus 1 standard deviation, the mean minus 2 standard deviations, the mean minus 3 standard deviations, the mean plus 1 standard deviation, the mean plus 2 standard deviations, the mean plus 3 standard deviations. The mean, median, and mode are all equal, relatively equal, all right, we should say. It's bell-shaped, so that's why it's also called the bell curve, and it's symmetric about the mean. So that implies, I don't want to say mean again, that implies that like this is symmetrical to that, or this value is necessarily won't be equal, okay, but it'll be symmetrical, meaning like the area from here to there is equal to that area. All right, notice this line right here and right there, it never crosses that x-axis. It always just kind of hugs it. Okay, we don't necessarily, I mean, I'm not going to really be worried about those inflection points. You don't worry about that. All right, this guy is pretty important. So the total area under that curve is 1. Now here's why that's important. That means the area under that thing equals like 100%, right? And so like we learned that from here to here, oh, that's kind of off, was 68. And then from there to there, there, what happened, was 95. And then like the area, right? So when I talk about area, I'm just talking about like just that piece inside that curve, okay? And then from here to here, that was 99.7. All right, those were like the percentages I asked you to learn. We're going to, that means that like 99.7, right? And so it's approaching 100. Okay, it approaches 100%. It can never get to 100% because the majority of the time we don't have like the entire population. Now, when we do some calculations and we do different tests and we do different formulas, we kind of assume we have like 100%, but you know, like even with the the census that the U.S. does every year, you can't get 100% of the people that live in the U.S. You have illegal aliens, you have people that are homeless, you have people that like to live off the grid, and so that's why that line never touches. Yeah. All right. Okay, so here, so we did discrete probability distributions, and that was looks so freaky with right there. Okay, with the two faces on top of each other. Okay, so discrete probability distributions was like, oh, how many children do you have? And you make a little graph. And if there's like one girl, and that's if there's two girls, three girls, no girls, or whatever. And so it makes a little bar chart, little histogram. And so if we look, if we look, it makes this wonderful bell shape. We did the binomial distribution, and so that one kind of looks like the bell shape, but your options were only like yes or no. You made it, you didn't make it. There were only two options. Versus here, like this would be like how many times option A came up, and this would be like how many times option B came up, and that would be how many times option C came up, and those bars, those lines, make just a nice little curve, and so that's how you get that. Okay, I don't need you to worry about that formula. Okay, it's there. Just know that we use that formula to make these curves. We're never going to reference it. I'm never going to ask you for it. Just letting you know that there's this insane formula, and it is the basis for all this. All right, so we did discrete probability distributions, okay? And so we're going to use what's called probability density function, PDF, and we'll also use that CDS, cumulative density function. Okay, the only reason I'm telling you these things is because when you press distributive, there's it, like second bars on your calculator, these are the things we'll use in our calculator to calculate a different some things, and so that's why I just kind of want you to know why it's called PDF. Right, and then this is you push second. You don't need to necessarily push y equals. You don't need to do that. Just second dist, or like distributive function. What is it? Density function. And then we'll choose one or two depending on where we are. Right. Also, totally reminding you about the negative distribution, the positive distribution. You only look at the tail, okay? Negatives are the left skewed and positives are the right skewed. And this is like this right here. Pretend that's a straight line. Okay, that is how many times the number 100 came up. Okay, this is how many times 80 came up. This is how many times 140 came up. Okay, and the curve comes from taking all that data into this insane formula. I'll never make you do that, by the way. Just letting you know. Okay, and then the right skewed, positively skewed data is where the tail's on the right and the hump is on the left. Remember, this is the mean, median, and mode is all pretty much right there. All right, and so the standard normal distribution, remember this right here, there it is. We just go with 68. This guy we just go with 95, and then we'll do 99.7. This is the mean minus 1 standard deviation, mean minus 2 standard deviations, mean 3 standard deviations. Right, now here, all right, so we talk about how, the area under this curve is 100, okay? 100%, or the area under the curve is 1. Remember, if I have, flipping a coin, the probability that it's going to land on heads is 50%, or 0.5, or 1/2. All of those are the exact same. And so the probability that happens, that's heads. Okay? If we did tails, it would be the same thing, 50 or 50%, or 1/2. And then if I added those two up, I would get 100%. All right, and so this curve is saying, okay, if we add up all the possibilities, the different events, and the frequency that they occur, we're going to get 1, right? So this guy, when you add it, equals 1. This guy, when you add it, equals 100%. This guy, when you add it, equals 1. Right? And so that's why we say the area equals 1. Okay? So the value under the curve, for example, I don't know, 1.5 or -2 or whatever, is the proportion of area in the section. I'm going to kind of expand that more. Okay? Really just understand that you can convert the percent to a decimal. And we're coming up. Where's the... Hang on. I don't know where the most important thing is, but area, when we calculate it, what we're really calculating, okay, and this is going to make sense in the next 3-4 videos as I explain the whole concept and we practice, is the exact same as the probability, this is an L, of the event. I cannot stress that enough. When we find the area, okay, area to the left is something, area to the right is something, area between two values, what we're actually finding is what is the probability that will occur, right? I cannot stress that enough. When we find area, we're really finding the probability that an event's going to occur, right? And to do that, these guys right here, it's a z-score of 0, which means that's how many standard deviations, right? It's a z-score of -1. That's a z-score of -3. Okay? And those z-scores correspond to an area. So for example, if something happens and it's 2 z-scores below the mean, it means that, or it implies that, the probability of that happening is, according to these figures, we use the rounded figures, is 0.13 plus 2.15. So 2.28%. Okay? I'm going to spend several videos explaining this, not just with words, like just math, so you can see the concrete numbers. All right, and so the basis of all this is the z-score. Remember, the z-score is the z-score. It's called standard score. The number of standard deviations away from the mean. Okay, remember the mean is 0. And then you have each of the things. I want to show you. It normalizes it. All right, so for example, great, 0, 1, 2, 3, 3. Pretend that's like perfect. Nothing about me perfect. All right, so you have an IQ test, just the standard IQ test, has a mean of 100, and then the standard deviation is 15. So 85, 60, 45, 115, 130, 45. Okay, it takes those scores, regardless that the test, it's not out of 100 points, the mean is 100, regardless of like how much the test is out of, how the standard deviation, and it lays those scores out on a very nice graph. If we took another test and like the mean was, I don't know, 70 and the standard deviation was 7, I think that's right. I just did it really quick in my head. It still standardizes it. All right, so let's do in the next video some problems.